All right, welcome everyone. We are going to be talking about the law of cosines today. We just finished talking about how to use the law of sines to solve for missing sides and angles in triangles that are not right triangles. And one of the things that we mentioned was when you are using the given measures to find all the unknown side lengths and angle measurements of a triangle, that is called solving the triangle. Okay, solving the triangle. And that's what we're going to continue to do here today. We are going to find all missing sides and all missing angles. Now, the combination of information that we're given on today's problems is going to be a little bit different than what you were given for the law of sine problems. Some scenarios, you're going to be given all three sides. We call that SSS. Okay, and there'll be an important note here that we always want to make sure we're finding the largest angle first. But let's just take a quick look here at what the law of sines is referring to, and it's going to be used in these two instances, in the scenarios where you're given two sides and an included angle, or where you're given all three sides and no angle at all. One other thing worth noting is we want to always make sure that your calculator is in degree mode for these problems. Okay, so the law of cosines, the way that this operates, and maybe these formulas look a little intimidating at first, but you'll notice, remember, the lowercase letters are all describing sides, and the capital letters, those are describing the angles. So there's only one spot in any of these formulas where you are actually plugging an angle in, and that's what comes all the way on the right side following cosine. One thing that I want you to note here, though, is that whatever the angle is, whatever the side is that's squared on the left, that same angle is on the right. So if you've got b squared on the left, you've got cosine angle b on the right. Okay, that's worth noting here. Okay, so let's just jump into this first problem. Take a look at how this is going to work here. Okay, if you're provided a picture, great. If you're not provided a picture, it is important that you always draw a picture and put the given information on it. Okay, we're going to be rounding our sides to the nearest hundredth and our angles all the way up to the nearest angle. You can see in this particular problem, you're given a side, you're given another side, and the angle you're given is included in between those. So this problem is a side angle side problem. Now you can tell by looking at this that the law of sines is not going to work for us here, because the law of sines requires you to know an angle, and you also have to know the side opposite that angle. And we are not given any of those three pairings. And so that's where the law of cosines comes in. With this particular situation, side angle side, you want to focus on the one angle that you're given. Angle B is 36 degrees. Now, if angle B is 36 degrees, then we're going to try to find side B first. So if we're finding side B, I'm going to kind of focus on this middle version here of the law of cosines. And we're going to start by putting side B squared on the left side, because it's always the side squared on the left. Okay, what you'll notice, there's a bit of a pattern here. After the equal sign, it's each of the other two sides squared and added up. Okay, so we can see the other two sides you're given is 5 and 7. So we're going to fill in 5 squared plus 7 squared. Okay, after that, it's minus 2 times the product of those same two sides, just not squared. So we're going to fill in minus 2 times 5 times 7. Immediately after that is where you write cosine, and then it would be angle B. Okay, now we know angle B in this problem, angle B is 36 degrees. So you're going to substitute 36 degrees in for angle B. Okay, now what we're trying to solve for, remember, is side B. So you can see that's already almost on the left side by itself. Everything on the right side is all just values that you could plug into the calculator. So you're going to grab your calculator and you're going to type the entire right side into your calculator. Now, ideally, you would not want to round this number at all. I'm going to kind of carry it out a little bit here when I'm writing it on my paper. But you're going to type all of this in. Important, you're in degree mode. You're going to see a number roughly 17.3688. And then what you will do is you will then take the square root of that entire answer, and this will reveal to you what the length of side B is. Okay, as you find these missing parts, we always want to make sure we're adding them to the picture. So side B is 4.17. Okay, now it is important that when you are doing the law of cosines, you make sure that you continue to use the law of cosines until you have found the largest angle, right? The largest angle. So I can tell by looking at this triangle that the largest angle is actually angle A. Okay, that's how I know. Now, I'm not basing that on how the angle looks. I'm basing it by looking at what my three side lengths are. Okay, the biggest side will always be opposite the biggest angle. So I want to continue to use the law of cosines until I have found the largest angle. This has to do with that ambiguous case that we talked about with law of sines. I know if you're thinking right now, like, why can't we just use the law of sines now that we know an angle and a side opposite that? But we can run into some trouble if you haven't revealed the law, or I'm sorry, the largest angle first by using the law of cosines. So I want you to make this note to yourself. Use the law of cosines until, okay, let's underline the word until, the largest angle is revealed. Okay, this has to do with making sure that is this an obtuse triangle or is this an acute triangle? Otherwise, that ambiguous case where there could be two triangles, we don't want to run into that if we jump to the law of sines right now. Okay, so I'm just going to draw a little line. My next goal then is I want to find angle A because I know that's going to be the biggest angle. Okay, so if I'm going to find angle A, then I want to make sure I jump up here and I use this first version of law of cosines because angle A is over here after cosine. Okay. Now remember how this works. Whatever angle goes over here after cosine, all the way on this side of the formula is that side squared. So that's where I want to start. I want to start over here with the side A squared, which would be the 7. Okay. So I'm going to plug in 7 squared goes on the left. Okay, according to the formula, it's the other two sides squared. Okay, well, my other two sides are, the 4.17 and the 5. So I'm going to do 4.17 squared plus 5 squared minus 2 times same two sides that I have there after the 2. So the 4.7 and the 5 is what I'm going to put. Okay, after that, I put cosine. Here's my variable, angle A. Okay, now this is going to require a little bit more algebra than what I had to do up here, because up here when I was finding side B, it was like the variable was almost by itself on the left. Here, there's a lot of other things that are attached to this A. Now, I want to make sure that you're careful here. All the stuff directly in front of the A is attached to cosine A by multiplication. So what we're going to want to do next is we're going to want to square the 4.17 and square the 5, and I'm going to add those two together. So we've got 49 on the left, and if we square these other two and add them up, I get 42.3889. Okay, I'm also going to multiply the negative 2, the 4.17, and the 5 together, and I'm going to put minus 41.7 cosine A. But this is all attached, so I have to keep that separate. Okay, we're going to subtract the 42.3889 from both sides here. Okay, so 49 minus that. Okay, and then we're going to divide both sides. Okay, whoops. There we go. We're going to divide both sides by negative 41.7. Okay, so let's see here. That gives us, okay, kind of a crazy number here. I'm going to write it down to a few places, but I'm going to keep the whole number on my calculator screen. Okay, now keep in mind, this number right here, this negative 0.1585, that is not angle A. That's what cosine of angle A is. So remember, when you're solving for angles in a triangle here, you have to do the inverse of that trig function in order to get the angle. And what I'm actually going to do on my calculator is inverse cosine of this whole entire decimal. And that will reveal that the measure of angle A is roughly 99 degrees if I were to round that to the nearest degree. Okay, so I should have been writing these missing parts over here on these blanks as I was going here. So I'm going to go ahead and circle them. As you find them, always make sure that you add it to your picture. Okay, well, once we know two angles, whoops, I did not add that in the right spot, did I? Sorry. Okay, angle A is 99 degrees. Okay, once we know two angles, we can add the two angles together. So 99 and 36, that would be 135, and then subtract 135 off of 180, and that gives us what the measure of angle C is, that last piece. Okay, so you can see here we've got a completed picture and filled in the blanks with all the missing sides. Okay, very, very important that we're using the law of cosines until we have revealed the largest angle. Okay, let's go ahead and take a look at a second problem here. This one does not provide a picture, so we're going to go ahead and sketch a picture first. This is triangle FGH. When you guys are drawing these pictures, the pictures do not need to be drawn to scale, so don't worry about that. You can see the information is angle G is 82, angle F, or I'm sorry, side F is 6, and side H is 4. So this problem, again, feels like it is a side angle side problem, and your hand is kind of forced here at the beginning, because as you look at this, you can see, once again, you cannot start this problem by doing the law of sines, so we're going to have to do the law of cosines. And our only option for a way to start this is, I think, for us to use the one angle we're given, because if you look at the formulas for law of cosines, you do either need to be finding that one angle or you need to be given that one angle. Okay, keep in mind with the formula, whatever angle you have here, exactly opposite over here on this side, is that side squared. Okay, so on this problem, we are given angle G. So I think we want to set this up where all the way on the far right, we've got cosine G. Okay, whoops, sorry, I'm kind of messing this up here today, aren't I? Okay, that would be cosine G, but we actually know cosine G. That's 82. Okay, what we're really looking for here is we're looking for side G, okay, which we want to put that over here on this side. So you can see how these are opposite, side G squared, angle G. Okay, what gets filled in this gap is information about the other two sides. So it's one of the sides squared plus the other side squared minus 2 times, again, each of those sides, and that gets multiplied times the cosine of 82. Okay, now this is a little easier, the law of cosines, when you're solving for a missing side. You're going to type this whole right side all at once, all into your calculator, and this will equal what G squared is. Okay, and then after that, you would take the square root of both sides. That gives you 6.73 units. So I'm going to add that on the blank. I'm going to add it onto the picture. Okay, now you want to look at the picture and ask yourself, do we know the biggest angle? Like, what is the biggest angle? Well, the biggest side is actually 6.73. That's the side we just found. So I think the biggest angle is the 82. So once you have confirmed that you already know the biggest angle, you can go ahead and use the law of sines. So just make this little note for yourself. So if you look back at your notes, this makes sense. Since we know the biggest angle, we can use the law of sines to finish. Okay, so let me go ahead and circle the pairing that we know. We know angle G and we know side G. So we can go ahead and we can set this up for law of sines, sine of 82 degrees over 6.73. Okay, it technically doesn't matter which of the other two sides you find next. I'll just find them in order from biggest to smallest. Sine of f divided by 6, and this is what we're quite familiar with, where we just cross multiply and we are solving for angle f. Okay, kind of zip through this here. Okay, at the end of this, we need to do the inverse sine to get this f by itself. So this is a really big thing you're going to type into your calculator, but we have been doing that for quite some time now with law of sines. And this would round to 62 degrees for angle f. So once again, put it on the blank, put it on the picture, and then you're going to add 62 and 82 together. That's going to give you 144. Okay, and the remaining angle has to be 36 degrees if there's 180 degrees in every triangle. Okay. All right, we're going to pick up the pace a little bit with these last couple. Okay, because we haven't done any yet where we are given all three sides. You'll notice this is triangle ABC. We're going to need to draw a quick sketch here. Angle A is 16. Side A is 16, side B is 9, and side C is 10. So in this example, this is a side problem. Here, we are given none of the angles at all. Okay, keep in mind, you need to be focusing on finding the largest angle first. So I'm going to highlight the largest angle. I'm looking at these three sides. I see the biggest side is side A, 16. So that means angle A has to be the biggest angle. So when I set up the law of cosines, I'm going to be putting side 16 squared on the left. All the way over here on the right will be cosine angle A. That's where my variable is. And I fill this gap in with information about the other two sides. They get squared and added, minus 2 times each of them multiplied together goes right in front of cosine A. Okay, from here we're just going to square off some of these values. Okay, so let's see, we've got 16 squared, that's 256. You can add together 9 squared and 100 squared. We're going to multiply the numbers together in front of the cosine, but please keep in mind you absolutely cannot subtract 180 and 181 because we have cosine A attached. So from here, you have to subtract 181 from 256 and then divide by negative 180. Okay, after you have performed that division, we can then solve for angle A by doing the inverse cosine. Okay, so inverse cosine. All right, we're going to round this to the nearest degree. Measurement of angle A would be 115 degrees. Okay, so you can see my picture is obviously not drawn to scale because that is obtuse. Now, the next question is, look, if you have the largest angle, then you can go ahead and finish this problem by doing the law of sines. Okay, so we found the largest angle first, so we can go ahead and finish this problem by setting up our sine of 115 over 16, and I'll go ahead and pair that up and find the next biggest angle first, which would be angle C, and then we're on our way with just cross multiplying like we're used to here. Okay. Okay, after you divide by 16, that's when you do the inverse sine. Okay, and I believe this gives you the measurement of angle C is roughly 35 degrees. Okay, 35 degrees here. So I'm going to add that to the picture, and then we just add the two angles, and whatever is left has to be angle B. That would be 30 degrees. Okay. All right, let's do one more where we're solving the triangle. This is another side. Okay. Angle AB or triangle ABC again here. Okay, looks like side A this time is 5, side B is 11, and side C is 8. I'm going to highlight the biggest angle. The biggest side is 11, so that means angle B has to be the biggest angle. I want to focus on that and find that first. So I'm putting side B squared on the left, all the way on the right, cosine B. Filling in the middle information about the other two sides. You can kind of see the pattern here, which is nice about the law of cosines. Okay, there is a bit of a pattern. All right, so we're going to add these together. It gives us 89. And multiply those. All right, and divide by negative 80. And then at the end, inverse cosine. All right, so let's see here. Inverse cosine. That gives us the measurement of angle B is going to be about 114 degrees. Okay. All right, well, that is definitely the biggest angle. Okay. Honestly, the problems where you might have to do the law of cosines twice in a row is really for these side angle side. And it happened on this first problem we did, because we are forced to find the side opposite the angle you're given, and that might not be the biggest angle, but that's where you have to start. And then you might have to do the law of cosines a second time in a row to then find the biggest angle. But with the side, side, side problems, which is what this problem was, a side, 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 you can just right away find the biggest angle and you're fine. Okay, so we've got this pairing. So to finish this problem off, we can finish it with the law of sines. Okay, we're just going to cross multiply here. All right, and let's see. This ends up being this angle, measurement angle C is roughly 42 degrees. Please make sure that you're drawing pictures and that as you find the information, you are adding the information onto the picture. Okay, that last angle A is 24. Okay, the very last problem we're going to look at is really just, we're not going to do this entire one. It just says determine whether the triangle should be solved by starting with the law of sines or with the law of cosines. I want you to look at the information you're given here. It feels like you're given two sides, and that angle 107 is actually not an included angle. I'm noticing we actually have, starting out, an angle and a side opposite. So it feels like this problem could be started out with the law of sines. Okay, all right, your homework for this particular section is the worksheet 12.5a.